There are three reasons why most people aren't learning faster despite using AI. First, most people are focused on the wrong thing. Which model to use, prompt engineering, the latest tool, Perplexity, Claude. But the people that are getting faster are doing the harder, boring work. They're trying new learning strategies, they're picking up new techniques, they're reflecting, they're iterating on what works. And arguably, this is less exciting than testing the new AI tool and the new version of Claude, but it's also exactly why so few people do it. Second, the people that are using AI, people like they're using it for everything, even though AI is not good for everything. They're not being strategic about when to avoid using AI. And by using it mindlessly, people are offloading the cognitive effort that produces the higher quality learning in the first place. And third, finally, since everyone is using AI, it no longer is about like whether or not you use AI or not. It's about when and how you use it strategically. And that's where the actual advantage is right now. Based on the hundreds of conversations that I've had with students and professionals that I coach, by teaching them three specific strategies that combine AI with how your brain likes to learn, they've been able to go from just using AI with just like really, really minimal benefit from then tripling or quadrupling their learning speed and still feeling in control of their learning. I do this myself, which is what actually allows me to work full time and study full time simultaneously. The third strategy is the one that surprises the people the most because it's actually about when you should deliberately avoid using AI altogether. The first strategy that we have is priming. And priming is one of those strategies that sound very, very boring to do, but actually make a very big difference. So, especially with AI nowadays, people want to get right into the material. They want to get straight into using AI, prompting it, asking it for all this information, putting all the prompts in. But just adding a small window of time before your main learning event is one of the highest ROI changes that you can make. So, quick theory time. When it comes to learning, one of the principles or one of the theories that explain how we learn effectively is what we call schema theory. Your brain learns effectively when the information that you're learning attaches to existing information. When new information arrives in and there's nothing to attach it to, your brain has to then build that information and that framework. And if your brain has to receive the information and build it at the same time, that's just too much to do. Your brain's not able to do that and it just gets rid of the information. And so retention breaks down. What priming is, it's super simple. Just before your lecture, before your meeting, before your study session, allow yourself to have a block of time where you develop some prior knowledge, some exposure, some sense about what the content is going to be about. And again, you're not studying here in depth, you're not learning in depth, you're not taking like really, really large notes here. It's just allocating a little bit of time to get familiar with the actual topic. And again, this applies if you're a student, it applies if you're a professional. Your priming window might just be skimming the lecture slides. It might be just taking a look at the chapter headings. And if you're a professional, it might just be taking 10 minutes to quickly take a look at the agenda of the meeting or the purpose of the meeting, get a sense of a tool or a framework before you start using it for a project. So again, if the context is different, that's fine because the principle of priming is identical. You want to have some time, you want to give yourself some time so your brain has something to work with before the main deeper learning happens. And if you're subscribed to the channel, and if you are doing things right, you might already have a version of this. You've got pre-reading going on, skimming the slides before a lecture, just having a quick look before you dive in. And that counts. That does count as priming. And even if you are doing that, just allowing yourself to have a priming session to get familiar with the content before you engage with it properly, it's extremely powerful on its own. So the reason priming matters as the first strategy is because strategy 2 and 3 actually happen within the priming phase. And without this block of time that is not in your schedule, it becomes really, really difficult to actually make efficiency gains that we're going to cover from these strategies that we're about to talk about. So again, this is the foundation. You can see it's got nothing to do with like necessarily changing the AI tool that you use or, doing this new prompt. You're just being strategic with what you do before that main block of learning by just having a time boxed bit of learning, a time boxed schedule block of time where you can just get a lay of the land. My recommendation is to have a priming session that's at least 5 minutes maximum 30 minutes. If you're doing very deep learning, I'd say absolute maximum 45 minutes. We don't want the priming session to last too long. We want to make sure that it's short enough where we are forced to prioritize information and we'll also feel that pressure. So make sure you've got that in place, because strategy 2 and 3 answer the question of what you should do in these priming sessions. And we're going to specifically talk about how AI plays a role in strategy 2 and 3 within this priming session. Strategy 2 is about what you do in that priming window, and this one involves AI. Pre-testing is exactly what it sounds like. Before you touch any of the material, no textbooks, no lecture slides, no documentation, you test yourself on it first. You use the information the way that you're required to use it after you do all that deep learning. So the point here is that you actually do it before. You try using information and recalling information that you fully don't know yet. Now, when I tell this pre-testing effect, this pre-testing strategy to many people, the first instinct is to avoid it. The question that they have is like, how can I test myself if I haven't learned it? But this instinct is incorrect, and the research is quite clear on this. Basically, what is mentioned is that the attempt of trying to actually do retrieval, even if you get it wrong, it creates a condition in your brain that actually makes the learning that happens significantly stronger when you encounter the correct answer later. Your brain made this prediction, it was wrong, and that prediction error is actually what drives deeper learning. And that correction sticks in a way that passive reading or exposing yourself to the material without getting things wrong does, right? So that's actually one thing, and that's the reason why maybe if you make a mistake in your experience, you remember that mistake a lot more compared to something that you got, right the first time around. There's also that dimension of schema theory here. You're using prior knowledge to actually just go through that and go through the motions of using the information in a way. This is where AI is useful, because you don't have to design the whole test yourself, and you can actually use pre-existing materials to get AI to either generate or gather it for you. So I'm going to show you how to do pre-testing in 2 situations. So first, a structured situation, a structured environment. For me, I'll show you how I'm using this for my psychology end of semester exams. And then second, an unstructured learning environment. So this is a project where I actually had to get familiar with a new tool that I've never used before, and I was able to use the principle of pre-testing to get the lay of the land of that tool and get right into learning it. So let's get out the iPad, let's do some drawing, and let's demonstrate this to you. Okay, so you can see we've got the iPad screen open, and on the left-hand side, I've got the AI provider of choice, which is Claude. And again, it's relevant because the effectiveness on your learning is not based on whether or not you use ChatGPT or Gemini. It is how you approach using the tool. So I'm personally using Claude because I also have the premium version of it as well, so I don't run into any limitation issues. But you can keep the one that you're using. That's not the one that makes the biggest difference. And if anyone tells you, hey, use Gemini because it's better for learning, and they don't give you any tangible changes as to how you can use the AI and how you can approach your learning, just run from them, just block them, seriously. Okay, so let's get into it. Strategy 2, pre-testing. Again, we've got that priming strategy in place where we are protecting time. We've got at least a 5-minute block of time, maximum 45-minute block of time, where we can actually get familiar with the content. And then we've got our main learning event. This is where we are spending a little bit more time diving into depth. And if you're in a structured learning environment, this means that you're probably studying in a lecture, a structured like seminar kind of setting, work, classroom, whatever it is, workshop. And if you're professional workshops, it's going to be self-learning, whatever it is. That's when you actually dive into depth. But yeah, that's the priming phase, and we've got pre-testing as a strategy. So I've got 2 materials out here. I've got structured, which is going to be a demonstration of how I'm going to use this for my psychology end of semester exam. So this is going to be on cognitive psychology. And we've also got unstructured here, which is me having to learn about a tool called N8N. And I had to build a few automations and a few AI flows for the team at work. So I'm going to demonstrate how I use the pre-testing effect for both of these environments, starting off with the easier one, in my opinion, which is going to be the structured learning environment. So there's 2 ways that you can use AI in this situation. First, we can use it to generate us questions that replicate the way that we're going to be tested. So again, the point is, when we actually finish all this learning, in a structured environment, you usually have an exam that you're actually going to sit. And this exam is going to have a few questions, it's going to have a few ways that you're going to be assessed. And with pre-testing, you want to replicate your assessment needs, your retrieval needs, and you want to create question stems that allow you to actually get into that zone. So you can use AI to either generate them if you're in a situation where you don't have access to a practice bank of questions, or you can use it to gather and prioritize them for you. So if you're in a situation where you do have a lot of practice questions on your plate, you can just give it to AI and help you sift through all of those practice questions. Alternatively, you can use a web search feature that AI has access to, and it can go through different courses or different blog posts that might, or like different, Reddit channels and other places where people post, official practice problems, and you can gather them there. So the things that I would actually feed into the literal AI itself is going to be a combination of this. Number one, it's going to be the scope of your exam that's coming up, or of the study session that you're about to have. So I'm just going to talk about it in a lot more simpler terms. Let's say, for example, I'm about to do a main learning event. I'm about to go into a workshop or a seminar for object recognition. Let's just say it's going to be week 2, object recognition. What I'm going to do is I'm just going to take a look at all the keywords and all of the related objectives, the learning objectives and the learning outcomes for object recognition. And then what I'll do is I'll take a practice problem that is just the general structure of what I could expect to come up in the exam. And then what's going to happen is I'm going to feed that into Claude here, and I'm just going to ask it to generate an exam question, exam style question that I could get for object recognition. Now, the amount of questions is really up to you. If you want to do 5, if you want to do 10, I just find 3 to 5 to be the sweet spot. And the point is, once we've generated these questions, we're going to try them out. And that's what that priming window allows us to do. So again, if you're only allocating 5 minutes for a priming window, it is tough, but potentially just generating like a quick multiple choice quiz could be useful if that's what your quizzes are. And most people, if they're in structured learning environments, from what I understand, and our university doesn't do this, but there's like, weekly kind of quizzes that are multiple choice. So you could do that. If you've got a little bit more time, if you've got 30 minutes, you've got 15 minutes, this is where you can actually sit down and do more of a fleshed out practice problem. And again, it does depend on the amount of time. In this situation, I'm just going to do one. It's just a bit more easier. And it does depend on the scope. If you're going to be doing all weeks at the same time, which is what I personally like to do, that means that your priming window can increase. So I did mention in the past, it's going to be 5 to 45 minutes. I just find that to be for one topic if you're studying at a time. But if it's an exception and you're cramming, that priming window could be up to 60 minutes. That's acceptable in these situations. 60 minutes is still enough pressure, especially if I generate one question for each of these weeks. That's 10 questions to do in 60 minutes. That's still enough pressure, within that time window to make sure that I get on top of things. So that's what I want to do. And again, I'm just using it to generate it if I don't have an existing bank. I'm using it to gather if I do have an existing bank. And it's as simple as just getting those questions, using our brain to answer these questions. So we're going to use our existing knowledge, yes, before we even learnt the actual thing, and we're going to try our best to actually answer those questions here as well. So let me just quickly demonstrate it to you. If we just take a look here, you can see we've got, what is accessible, we've got the learning objectives. I'm just going to quickly take a look at that. I'm going to copy the text. I'm just going to give it. And then what I can do is I can do the exact same thing for the question stem here. Super, super simple. So let me just take this here. Here we go. And I'm just going to copy that. I'm going to paste that here, and I might even just speak into it. And it's super simple. I don't really care about the prompting as much. There's another thing I do want to mention here. We're about to generate something with AI. And a lot of people ask me, Tanziro, do I need to get really accurate? Should I prompt it? Should I give it all my material? Should I give it like previous questions? Should I give it marking keys? You can spend the time to do that if you want to do that setup. My principle is a lot of people just spend way too much time creating the model instead of using it. They create this model that works really, really well for like, their assessment needs, and it creates like a really beautiful question and it's always accurate, but they spend more time building it. So you don't want to get into that productive procrastination. Just get right into it. So I might just speak into it and just might say, Hey Claude, I've just given you a list of my exams that will come up, like the exam topics, and I've also given you a practice problem. What I would like for you to do is I just want you to create me probably around three practice problems for week two, object recognition, based on the structure that I've given to you. I'd actually say you could probably create one question stem and then three questions under that, and that should be more than enough. I'm just trying to do some testing and I'm just trying to test myself on object recognition concepts to make sure that I can get a lay of the land of where I am. There we go. Just using an app and I can just press enter. And now I'm just going to give it some time to think. It might take a little bit of time. Here we go. Nice. And you can see, here we go. We got a set of questions. We've got three here. And I don't really care about that part because I'm not too fussed about making sure that it's properly prompted. And I find in my experience, you don't really need to work on that either. Okay, so this is an example of us generating the question. So we can just take a quick read here. Here you go. Like this is a really good question. And so I actually don't really know the answer to the question because I haven't studied it. But I think it's got to do something with like shape recognition. Like there's a something here, shape recognition. I don't even know what the concept is. Um, I think it might be to do with like the brain's region. There's like a brain region called fusiform. I don't know what it is. I think it might be like shape recognition. Ah, no, no, no. There was a concept. There was a concept. It was like something to do with constructs. I remember that being there, right? So like I actually don't know the answer to this question. I'll be like very straight up. I actually just don't know. And there is an answer. I remember there being like an answer. It was like something to do with like yeah, it just shape recognition. There was definitely a framework there. You can see, but what I've done here though is I've made sure to not just give the answer I don't know. So I don't know, and I'm still gonna guess. Like that's the framing that you want. A lot of people when they do the pre-testing process, they just read question one and they're like, "Yep, I don't know." Next, and it's like, no, you don't want to do that. Like, just push yourself. I've had many consults in the past where I've trained people to try doing the pre-testing effect, and they get really uncomfortable with this process. They're like, "Tanzir, I don't know. Like I actually don't know. I can't think." And I just sit there. I'm like, dude, you have to give an answer. Just give your best answer. Just make something up. I just made this up. Shape recognition? What even is that? I don't even think that's like. So you can see, like, I'm starting to, like recall and retrieve the information in a way. It's a bit tricky. Another benefit of the pre-testing effect is that it warms your brain up into how you need to use the information. So a lot of people don't know how to actually use the information or think about it, especially if it's something new that you haven't studied before. You haven't sat like this exam format before. So that's what I would just do there. Let's do the second one using the framework of feature-based recognition. Explain why Maya struggled to recognize her regular customer with a new haircut. What does this tell us about the difference between holistic feature based? Okay, so I mean, with the haircut, I imagine it's something to do with the shape thing. Like you kind of, and when you do something like what's it? I remember it was like when you do holistic configurable face processing, your brain takes a look at all parts of it. It doesn't actually isolate between the two. And I remember actually doing a research project. If like your brain is able to isolate between them, usually you'd be considered potentially like a super recognizer, like you're someone really, really good at doing facial processing. But I think it might be to do with like the shape, the fact that holistic and configurable face processing isn't isolated to individual features in the face and of someone's hair. So when someone's hair changes, the holistic configurable face processing, like the schema that it builds, it's a bit different from what your brain's actually used to doing. And feature based object processing, I think that's again talking about how like your brain doesn't take a look at individual features; it takes a look at features together. And so if one feature is even different, your brain starts to think that they're separate. So that's my answer to that, and I might write that out. I'll write that out. I'll like type it out as if I'm doing the real exam. And now this is starting to like kick back. So remember, I just did that assignment like a couple of weeks ago, and I forgot about it. But now doing this and retrieving the information in a certain way is making me think about it again. Last one here: Maya's mistaken identification of the stranger as her friend Sam. Top-down processing, describe how expectations, context, and prior knowledge can lead to recognition errors, and link this to a relevant concept from the week's content. So I have no idea. I know there's top-down processing. I know there's bottom-up processing as well. Uh, yeah, so it might be something there. Expectations, context, and prior knowledge can lead to recognition errors, and link this to a relevant concept from the week's content. I can't remember that. Oh, so about priming, but this is a different type of priming. But you can see, like, I can't really recall, but I think maybe it was like something to do with, I don't know, system one, system two thinking. Maybe like her prior knowledge is her friend Sam potentially has like a really nice red jacket that she always wears, and like, yeah, I don't know. I don't know. Like maybe prior knowledge is associated with that. Uh, I already answered this question, but I feel like here it might be like an associative effect where the red jacket always triggers Maya's thinking that it's Sam, but it's not Sam. And there's something to do with that color and something to do with that personal relevance that made her think it was Sam, for example. So I think it might be to do along the lines with she has like this shortcut in her brain, the only for like a system one really rapid bias heuristic thinking like way of thinking about, well, cool, it's Sam, and because it's a red jacket, therefore it has to be Sam because I know Sam to always be part of the red jacket. So her brain has like trained that pathway. I think there's also parts about how the brain likes to actually take shortcuts to avoid like really really hard thinking, which is where biases come from, and biases aren't always a bad thing. So there's also stuff there too. Yeah, that's how I might answer that question. And you see, this is tough. Like I'm really having to like actually get out my mind. And that process roughly took us 5 minutes to quickly generate and answer the question. So you can see if you actually have a little bit more time, this is a lot more fruitful. You can start to think about certain keywords, think about certain concepts, and actually get into the groove of things. That's an example for how we would do it for a structured learning environment. Let me quickly go to an unstructured learning environment and talk about how we would do it for something like a project. I can quickly walk you through how I did it for NAN. Now, obviously, in a context, in a professional context, I am not going to be given an assignment or like a multiple choice quiz on NAN. Right? NAN, by the way, it's a low code flow tool, just like a visual coding tool. You can see in this screenshot here, instead of us having many like Python files and code bases and repos, it's just a really easy way of connecting all these nodes together. In this situation, it seems like that there's a AI process that sends like a feedback on Slack, and it uses OpenAI, and it has like some memory here too. And it uses another workflow here as well. So in this context of actually having to learn for work, learning a tool, what is the test? Right? We need to figure out how do we actually need to use this information, and how we expect it to then manipulate the tool and manipulate the frameworks that we're about to use. So obviously for a structured environment, the reason it's easy is because you usually have an exam and so you're told how to use it. But for an unstructured learning environment, you usually need to be a bit clearer as to how you need to use it. And this goes back into identifying project deliverables and the purpose of using certain tools and the problems in the business that the tool solves. And so I actually find it to be useful to use AI for two things. Number one, to discriminate, and number two, to determine. So usually before you actually start learning in a unstructured learning environment, a structured learning environment, it's about, like, it's about what to learn, right? Like that's what it is. For a unstructured learning environment, it's more so about what to achieve. Like that's the question that we're answering here. And for me, the NAN flow, the reason we wanted to actually use it was we wanted to quickly prototype a method for getting student or learner based profiles and getting a lot of the questions that they have, putting it through a chatbot, the chatbot accessing some of the prior knowledge and some of the existing IP that we have, and then being able to give a response back to the learner. Super, super simple, like AI application of it. And so For me, it's like, well, NAN is the tool that we're going to use in this pre-testing process. I might just quickly discriminate. And basically, this is like a super simple process. I don't think I need to show it here. I actually want to walk through my chain of reasoning as to why we are using NAN, what we're trying to do, and what we are aiming to build like by the end of it. And the reason discriminate works really well here with AI is that it's able to poke holes in hypotheses that you might have around tools that you might use, etc. And this is only important if you have like high stake decisions to make. So for example, if you are in charge in terms of the tech flow or the tech stack that we need to use, this is when you would have to spend a lot more time actually learning about the technological feasibility and the costs associated with using something like NAN, or the alternatives of using NAN, the weaknesses, the strengths of using it, etc. But if you are just doing it to prototype rapidly, well, then you don't need to really spend a long time in discriminating, so you can skip this step. So I do see this to be a little bit more relevant if there is a decision that needs to be made, especially in an unstructured environment, if you're responsible for selecting tools, and if the decision is irreversible. So if you decide to then move forward with NAN, now it's like, okay, well, and we can just move on to step two. But if that is still being decided, you still need to do a bit of deep thinking here. I'm not going to demonstrate that in this video just because I feel like it goes beyond just, like pre-testing for unstructured learning environments. It's starting to go into like decision-making tools and prioritization. But that's the process of discrimination that I would use there. I would just use AI as a way during that priming process to get a lay of the land. Like, is NAN the right tool to use here? Are there any and are there alternatives that exist here as well? What are the strengths of NAN? What are the weaknesses? What's the costs look like if we decide to go into prod and use NAN, right? Those are all things that need to be considered because, again, if you're in an unstructured environment and you are achieving a goal, fundamentally, the tool is usually irrelevant in itself. Like NAN itself as a tool does not have importance. It's about what it's going to achieve. So we could use FlowWise, we could use Lang fuses, like Lang chain, sorry, providers. We could use other low code tools. Maybe we don't even use a low code tool at all. Those are things that usually need to be on your plate when it comes to unstructured learning environments. That's what I find anyway, especially as someone who's part of like making decisions as to what platforms we need to use. That's where using AI during your priming process to discriminate can be quite useful. I know a lot of people say like you should jump right into using the tool, but again, like just that priming window, again, if your main learning event is using the tool itself and building things out and taking a look at a course on NAN, taking a look at YouTube videos on NAN, before you commit yourself to actually going down one tool, do the process of just priming, figuring out all the alternatives, doing your higher order thinking, your critical thinking, and then moving forward. Because if it's irreversible, that's very important. If it's reversible, you still want that to be in place. Okay. That's what it would look like. And then the second part could just be to determine here. And again, not too much of a complex step here, but what we could do is we could just determine the scope and determine either whether or not we just want to go build out the exact project in play, or if we just want to do like a smaller project on hand. So for me, I actually found it to do a bit easier to do a smaller project. So remember, the initial thing that I need to do with NAN was that we needed to connect it to our student CRM, and then the student CRM would then call NAN itself, and NAN would have its whole flow of then accessing our AI bot of choice, and then it would be connected to a vector store, and then I'd have to design that vector store itself. And there's also a lot of things about transcriptions here, also connecting it to our LMS. And so if there's new information that's live, it doesn't, we don't have to like keep going back and forth. And then we'd have to also do some prompt engineering here as well. And then we'd have to actually return that to the student CRM, and we'd have to have a tracing process here to make sure that we realize, the amount of tokens and the cost that was being associated there as well. We'd also have to have a tracing service for testing as well. So it was quite a complex flow. And because I was only getting used to it, and I was just like, dude, let's just do this part. Let's just actually just get the AI to work in NAN. And that's all I did. And then you determine what's the next step. Well, it could be then to just do this process here, connected to a vector store. And then it could be to potentially just have that tracing software. And then it could be to connect it to the CRM in some way, shape, or form. and just test the connection. And then it could be to connect the CRM to the actual AI and then connect the LMS. So you're like gradually getting there. This starts related to what we call project-based learning. And my priming process here might be super like short. It just might be that. And then I might move on to the main learning event, which looks very different compared to a structured environment, which is where I'm watching YouTube. I've got an out, I'm doing things, I've got AI on the side, I'm doing things there, and I'm going back and forth. But that priming process, that pre-testing process of where before I formally start doing this at work or using like the funds from work or using official materials at work, I might actually spend time doing a personal project and just creating one for myself and using that as like a priming window to just get into things. So that's an example of how we might do pre-testing in these different situations. There's many very different ways of doing this. For example, if your structured learning needs require you to actually do oral presentations, so I work with a lot of doctors, I work with quite a few doctors who are doing specialist exams, and in these specialist exams, they actually have an oral component. That means that you might actually quickly test yourself using an oral process. You might actually speak it out. So in that situation, it changes how you respond to these questions. Again, we actually type them out, but you might respond. So again, it's important that your pre-testing replicates the way that you need to use the information so you can do two things. Number one, reveal gaps, but number two, actually get your brain warmed up to get familiar with how you need to use the information. Strategy theory surprises people the most because it's deliberately about not using AI. It's called blind mapping, and you can use it as a replacement for pretesting or stack it on top if you have more time. And it does depend based on like whether or not you should do pretesting or blind mapping. It does depend on your needs. Leave a comment if you want some more help on that. But basically, inside that priming window that you should already have, before you go deeper into any material in your live learning event or your main learning event, you just get a feel for what already exists in your brain about the topic out onto paper. You explore those connections, you surface the relationships, you squeeze as much as you can out of your existing knowledge. The only place that AI comes in this part of blind mapping is at the start to give you the keywords to work with, but nothing else, just the terms. And then you just work with this keyword list and you map from there. So I'll demonstrate this with the topic of object recognition. So it's the one that I'm weakest with. So you can see how I'll struggle. And the benefit of something like blind mapping is that it significantly increases the probability that your brain will attach the new information that arrives during the main learning event to something that is already there. And it brings up something quite important. Prior knowledge is not an attribute. It's whether or not you have it or not. It's a strategy. Blind mapping, priming, and pre-testing are one of the ways, or some of the ways, that you can actually build prior knowledge deliberately and utilize the effects that come from building on top of prior knowledge. This is how you actually develop more retention in less time, and this is how you learn faster. Okay, so let's get into blind mapping. And you can see here, I've actually got the list out. I've got a few other videos that explore blind mapping as well, and you can take a look into those. But we're only going to do a really quick demonstration here, probably just for 5 minutes just to demonstrate. And you can see here, I've got the topics that I'm about to study, and we're just going off the trend that we're doing week 2, and we've done the pre-testing, or we haven't done the pre-testing. Strategy 3 is something you can do on top of pre-testing. It's something that you can do parallel to pre-testing as well. So you're going to do pre-testing and then you blind map and then you go back and forth, or you can just do it by itself. So there is a decision-making process behind it. It is a little bit more nuanced than saying, blind mapping is better than pre-testing. It really does depend on your schedule. I should say though, if you are newer to a topic, like you have no exposure to it whatsoever, blind mapping tends to be more friendly because when you give people pre-tests, they're like, dude, I have actually no idea what's going on. Like what is going on? Pre-testing is better if you are further down the line in your preparation. So for example, I'm actually about to do exam prep and I've already kind of studied some of these things. So if you're in that position where you've already done a few main learning events, etc., it can be worth doing pre-testing if you're further down the line. Ideally, you do both if you've got that time. But let's do this. So we've got week 2, object recognition. And again, the way that I'm using AI, I'm just going to use it for keywords. I'm not using it for anything else. And then I'm going to just go blind and try creating all these relationships. And the reason we're doing that is because we can form some meaningful prior knowledge, even if it's wrong, and we can induce those benefits from schema theory. We increase the probability that when we actually go into that main learning event that we have, we can attach the information onto something else. And that attachment is actually what develops retention. And that retention means we forget less, which means that we're faster at learning because we're forgetting less and we're having to relearn less. So let's actually do this demonstration here. I can just go into I can go into Claude, I can go into whatever tool that I'm using, and this is the specific prompt that I'd give it. Hey Claude, I need you to generate a list of 30 keywords for object recognition that I'll probably be assessed on for my exam based on the context that you already have. I don't want you to group this list, and I just want you to give it to me in a random order. Here we go. Let's go. Oh, I love that. I have no idea what all these words mean. No, I kind of know some of them. So this is great. This is the process that we have here. And I'm just going to take a screenshot of that. Here we go. I'm going to copy that here as well. And then we can paste it here. Right? And this is the process of blind mapping. We are going to use the prior knowledge that I have about object recognition. And this process is going to get my brain to really explode because I have no idea about any of this, but I'm going to attempt to build a structure. That's all I'm going to do. So what I'm going to do is I'm just going to take a look here real quick. I'm just going to set a timer really, really quickly. Let's just get that timer going. Start timer. And I'm just doing this on my laptop. I'm going to set it for 5 minutes, right? However long your priming window is, you should set it for that. I should say a technique like blind mapping works very well when there's time pressure. So even if you have a lot of time, I would encourage you to still make sure that you have that bit of time that feels uncomfortable. 5 minutes is definitely on the very, very uncomfortable end, but I've done it many times. If you're on the bus, on the way to university, for work, etc., you can do this process. This process doesn't really change if you're in a structured environment or an unstructured environment. The only thing that I'd see that would change in an unstructured learning environment is that you probably have just less content to work with in my experience, and it's just going to be more tactical. There's going to be more tutorials, there's going to be more like steps involved in terms of your actual learning process, right? Like you got to do this is more process based, it's more project based. So let's start a timer for 5 minutes and let me quickly show you this blind process. So again, I'm not using AI, I'm not using Google, I'm not jumping to a textbook. You can see, I'm just going to be using my brain. Let's go. So timer has been started for 5 minutes. Let's get into it. Geons, I have no idea what that is, but if I had to guess, I feel like geons is like like parts of the brain where like things that your brain sees, like I don't know, yeah, something like that, right? Or maybe it's like things in your eyes that your brain uses for pattern recognition. I'm just gonna say, yeah, like brain and then eyes, and your eyes tend to notice geons. I think geons is like features. I have no clue. I literally have no clue. I'm blind. I'm just really blind here. Pandemonium model. Ooh, I have some prior knowledge because we did a practice question. All right. I know that the pandemonium model, it's like it's like something that explains object recognition. Object recognition, like the mechanism behind how it works. I think that's what it was. And then like mechanism here. And I think pandemonium model was one of them. I remember them. I remember it being one of them. I think so. Word superiority effect. I feel like it's got to do with object recognition, and it's probably to make it easier, or maybe like biases that our brain has. And something that's happening here is I think that's where the word superiority effect is. Not too sure. Let's keep going. Holistic processing. Okay, I could just use this keyword list as well. Holistic processing is when the full thing happens. Feature detectors, I feel like it relates to that. So holistic processing is, and recognition by components, they're like opposing one another. So I'm actually going to write that here as well. So there's going to be full and then partial. And that's the way that I'm thinking about it. And then we've got RBC here, and we've got holistic processing here. That's the way that I see it. I feel like it's like conflicting. You know what I mean? That's the way that I'm thinking about it. Feature detectors, I feel like it relates to that, like geons, feature detection. Here we go. And oh, how much time do I have? I don't even know. And it's going to be like a noise that goes off. Top-down processing, bottom-up processing. I feel like this has to relate with something to do with object recognition in itself, but like maybe the order of object recognition, like order is here, and then there's top-down, and then bottom up. I know from top down, bottom up what it means in business. Top down is like, where do we want to go? Bottom up is like, what do we have right now? So I kind of already know what that is. I think top down is more like system two thinking, and then bottom up is more system one thinking, and that's prior knowledge that I get from like Daniel Kahneman's system one versus system two thinking. So that's something that I'm seeing there as well. Template matching. I feel like template matching relates to how your brain like looks at things. So maybe template matching there as well. I think that's using prior knowledge actually. Ooh, prior knowledge. That's what we're doing right here. Uh, Priming. Oh, there's priming here. I'm sure this is a different priming. This is a different priming that's talked about. Fusiform face area. I know this is the part of the brain that actually does something. If I recall correctly, that's part of the brain. Prosopagnosia is like a process that your brain is not able to like identify faces very well. I said that way incorrectly. Prosopagnosia. That's how I think you say it. That process is like when your brain doesn't see it effectively. I remember that actually being something that I did. Priming, I actually don't know. I think priming relates a little bit to system one, maybe. Priming here. So does template matching, maybe. Like system one. I feel like template matching is like a really quick thing that happens. And then priming interactive activation model. I have no idea. Tachyscope. I feel like this, whatever the hell this is, it's like a measurement device because it has scope in it. So maybe like it's like maybe it's a device that actually measures how well your brain and how well you're actually able to do the recognition, especially for your eyes. Maybe it tracks your eyes. I don't know. Okay, letter recognition I feel like relates to the superior word one. So I'm just going to put that one there. Letter recognition. And repetition priming, this seems like a type of priming, so I might put that there as well. Interactive activation model, no idea, but I'm going to guess basic level categories. Feature integration theory. Feature integration theory feels like it fits here, like in the full thing. Feature integration theory. Here we go. And let's keep going. Distinctive features, I feel like relates to, again, that's like features, right? Maybe here. Distinctive features. Okay, there's a timer. We'll just cancel the time for now. I'll just keep going for a little bit. Object constancy. I don't know what that is. Uh, Demon hierarchy. Whoa, that's scary. Biogun detectors, contact, blah, whatever. There's cognitive demons. Wow, that sounds very scary. Okay, so I haven't gone to that part yet. Inverted face effect. This is getting scary. Okay, but that's 5 minutes. And if I was out of time, like I would actually just take this mess that I have into my main learning event. And hey, I only have 5 minutes. There's nothing else that I could do. And this is a process that I could use to quickly go through things. Now, if I had some more time, I'd actually go through just a few more of these and I'd add it somewhere. And then what I'd actually do is I'd integrate a process of chunking where I'd actually take a look at the themes so far of what I've got here and I'd try creating a structure that's a bit cleaner. So we can just do this so far with what I have. I think System 1 and System 2 actually made a very big appearance in this map. So that's going to be one thing there. There's going to be about something about the anatomy behind object recognition here as well. And there's going to be like research around object recognition in itself and the different mechanisms in which we do it. And there's going to be like so this is the biological component of it. This seems to be more of the psychological component of it, like the actual how it actually happens. Actually, nah. Yeah, I think it is. And this might explain more of the like processing speed behind it. The speed and the order of decisions, speed and order. So maybe this is the what? No. Yeah, I think it might be something like that. Okay. And then if I had to clean it up really quickly, this is my blind map, I would say that what I know based on this, there's going to be the biological component that is talked about. And the biological component then helps us understand the psychological aspect of it, like how it actually occurs in the brain. And with the psychological aspect, we can then take a look into the outcomes of the actually not outcomes, maybe implications. I think is a bit better. implications, maybe. I'm not too sure. And then you can see this is a bit more cleaned up. I'm doing what I call a backbone here. A backbone is just a collection of what the main ideas could be of the topic that we're about to study. And it's just like a really nice visual anchor to have in your notes. So you have like a clear, you have like a representation of what your brain is deciding to prioritize. I'm deciding to prioritize this. You need to do this process actively, because if you don't, like, nothing's going to make you magically just think about a backbone, right? And then there's something to do with like the brain. There's something to do with the eyes as well, of course. There's like parts of the brain, regions of the brain. And there's also going to be like, there's also something around like disorders of this process. Like there's that prosopagnosia thing that I remember reading somewhere, like difficulty recognizing faces. And then, like, based on that, there's like a way that you like, there's an order here as well. I think system one and system two was really like a really big one. Like system one was like fast, and then system two was like slow, right? And then it seems like your brain really favors system one over system two in terms of the order that it does things. And then there's like things that's going to be there, and I'd just add that. And again, if I had more time to clean up, I would. And then I'd take this cleaned up version of the map, and I would then take it into my main learning event. And this is good because now, like, I'm starting to just warm up my brain, and I'm just trying to get everything that already exists here and putting into the actual map. And this is great because I can then undergo the hypercorrective effect when I learn this more in depth. So when I then take this into my main learning event, meeting, seminar, workshop, class, whatever it is, even if you're doing self study, if I'm about to now go watch like a 1 hour video on object recognition, now I can actually just take the structure and be like, oh, I was wrong. That is not what that is not what a geon is, or geon. I don't know how to say that. Or, oh, I was wrong. That's like system one is not that. It's actually, this is what I thought was system two is actually system one, and what I thought was system one is system two. Right? Maybe I made that type of error. So that's actually where you get the benefits of doing this. And again, you can use AI here. You can actually then teach this map to AI, and AI can actually start to point you in directions that you weren't familiar with. It's like, oh, maybe you got that wrong. You weren't understanding this, etc. And a really cool way of doing that is you might actually have like a voice transcript software. So I'm using something called Whisperflow, and I might even teach it the way that I was thinking about the information. And I might actually go through this process of teaching, and then I might actually take a look at all this list, and I might just speak into it. And instead of getting the answers, I could just get some general direction from AI. And that can actually help me then go study and go in depth and actually add and build onto this. So this is the process of using blind mapping, which was our third strategy. So bring these three strategies together: priming, setting the window of time, pre-testing, sharpening what you need to attend to, and blind mapping, forcing your brain to actually do the hard work. This is the combination that actually changes retention and the way that you're able to use the information, and letting AI actually fuel a learning process instead of replace the learning process as a whole. So tell me about how you're using AI right now to learn. Drop it in the comments. I'm responding to every single comment.